Okay, we are now starting on the naming both ionic and covalent compounds worksheet number 3. Hopefully this is starting to make sense now. So first we're going to start with the chemical formulas and we're going to go into the chemical names. So with this one is Na and Br. Looking at the periodic table, we find that Na is on the left-hand side and bromine is on the right-hand side. That means we have a metal with a nonmetal, which means we have a cation with an anion. That means we're going to name the cation first, which Na is sodium, and then the anion next. Bromine becomes bromide. Now, if you look at the periodic table, you can tell that sodium's a +1. That means we do not need a Roman numeral in there. Okay, so number 2. Ca C2H3O2, 2. Ca is here, and C2H3O2 is acetate, which means that we have calcium with a polyatomic ion, which means it's going to be an ionic naming. So that means we're going to name the cation and then the anion. So the cation is calcium, and the anion is acetate. By looking at the periodic table, you can tell that calcium is a +2, which means that you do not need to have a Roman numeral there to determine the charge. Number 3. We have phosphorus and we have oxygen. Notice that they're both nonmetals. That means those electrons are being shared, which means it's going to be a covalently bonded compound. If they're both nonmetals, that means the electrons are shared. That means we're going to use prefixes. So, when we're looking at this, P is for phosphorus, 2 means diphosphorus, and then O is oxygen, which becomes oxide, and 5 is penta, so it's pentaoxide, so it's diphosphorus pentaoxide, or pentoxide. Number 4, TiSO4. SO4 is sulfate. That's a polyatomic anion. That's a clue right there that it's going to be an ionic compound. Titanium is right here on the periodic table. Notice you cannot look at the periodic table and determine the charge of titanium. That means that we are going to need Roman numerals in the name, so that way somebody else can figure it out. The sulfate, SO4 sulfate. I left a space there specifically for Roman numerals. Now these little numbers down here, that 1, that invisible 1 and that 2, that initially came from the charges of the cation and the anion. So that means that the titanium is a +2 and the sulfate's a -1. But if you look up sulfate, you'll find that sulfate's supposed to be SO4 with a -2 charge, which means this got reduced. So to unreduce it, I would have to multiply that by 2 to make that -2, which means that the titanium also needs to be multiplied by 2. So titanium is actually 4 sulfate. Number 5 is very similar. PO4 is phosphate. That's a polyatomic ion. Iron is right here on the periodic table, somewhere around there. You'll notice that if you look at the periodic table, you have no idea what the charges are for this area. Because of that, we have to figure out the charges so that way we can tell somebody else. So Fe is iron. Because I don't know what the charge is, I'm going to leave a space there for the Roman numeral. And then I'm going to write phosphate because that's the anion. I'm going to put PO4 in parentheses, even though it's not in parentheses right now, because that's a set, it's not going to separate. So When we uncross it like we did before, we don't want to cross that 4. We're actually going to cross the 1 on the outside. Phosphate, if you look it up, is supposed to be PO4 with a -3 charge. This has a -1 charge. That means I have to multiply it by 3 in order to get to be a -3, which means I have to do the same for the iron. So the iron is actually a +3, not a +1, or a +4, which are the two common mistakes. Okay, K3N. Looking on the periodic table, K is around here somewhere. You notice that that's a metal, and nitrogen's over here, and it's a nonmetal. You notice that also, if you look at K, you know by looking at the periodic table that potassium has a +1 charge. That means this time we do not need the Roman numerals. So I don't have to worry about those Roman numerals or crisscrossing. There's our cation. The anion is nitrogen, and it becomes nitride, because I take the base of the word and I end it with "ide." Number 7. Here's sulfur, and here's oxygen right above it. They're both nonmetals. Knowing that, that means that the electrons are being shared, and it's going to form a covalently bonded compound, a molecule, rather than an ionic compound. That means we're going to use prefixes. Sulfur is 1. If the first one is 1, you don't use mono. If the second one's 1, you have to use mono, but not if the first one is. So sulfur, there's no mono out there. And then 2 is di. And we have 2 oxygens, and oxygen becomes oxide. So sulfur dioxide. Okay, copper is right here. Hydroxide is actually a polyatomic ion. OH is a polyatomic ion of hydroxide. And that is OH with a -1 charge. That means those are 2 indications that this is actually an ionic compound. So we're going to use those rules. So that means we had to use the cation and then the anion. The cation is copper. The anion is hydroxide. If you look at where copper is, you can't determine what the polyatomic, or you can't determine what the charge is just by simply looking at the periodic table. That tells you that you need to have a Roman numeral in there, which means we need to uncross these, so that becomes a +1 and a -1 in order to determine the charge. Double check your anion. We have OH as a -1, and that's what it's supposed to be. That means we don't have to do anything else, and copper is just a charge of a +1. Number 9, NO2 is another polyatomic ion, that's nitrite, and that's an NO2 with a -1 charge. You'll find zinc right here, and nitrite is a polyatomic ion. That tells you that it's going to be an ionic compound because zinc's a metal and nitrite is an anion. Now, zinc is an exception to the rule. We have zinc and we have silver. Zinc is always a +2 and silver is always a +1. Those are the 2 exceptions of the middle area where we don't know what the charge is. Because those are always those charges, we don't need to have a Roman numeral in number 9. So it's just going to be zinc, nitrite. And the last one we're going to do for this video is V2S3. V is vanadium, and it's right here, and sulfur is right here. S is right there. Notice that there are 2 different sides of the periodic table. One's a metal, one's a nonmetal. That means it's going to be an ionic compound. Therefore, we need to write the cation, which is vanadium, and the anion, which is sulfur, which becomes sulfide. Notice where vanadium is on the periodic table. We can't look at the periodic table and determine the charge of vanadium. Therefore, I need to tell the next person what the charge is going to be. We have to determine that. We have a 3 and a 2. We have to uncross these numbers. So it becomes plus 3 and a minus 2. Double check your anion. Here's our sulfur. We have it as a minus 2. Look on the periodic table. Is it supposed to be a minus 2? The answer is yes. So that means that vanadium is indeed a plus 3. We don't have to unreduce it or multiply it. Alright, and that is your answers for numbers 1 through 10 of the naming ionic and covalent compounds worksheet number 3.